it's got to stick together. So. Second one. All right, guys, let's go and sit down. Let's get started. We have some awesome content to talk about here.
It's actually Matt's.
Yeah, seeds.
And then I think that's Michael's.
Okay, guys, let's go and get going. So, I'm really excited. Another little fanboy moment fulfilled. Get to introduce Mr. Michael McEvoy. Somebody I look up to a lot. I've taken 3 of his courses. I plan on doing all of them, budget allowing. We all get it. Spend all my money on education. So, Michael McEvoy is the founder of Metabolic Healing and the co-founder of the True Report software. Michael is recognized as a thought leader, clinician, systems creator, educator, and integrator of diverse clinical modalities. As the founder of the Metabolic Healing Institute, Michael recognizes the need for deeper clinical applications and clarity of vision in the field of functional medicine and integrated healthcare. So, Michael McEvoy on what is a super dope topic. See you guys.
Thanks, Brendan. What a great weekend, huh?
Yes.
It's been amazing. We're coming down to the last bit of it. You guys having fun?
Yeah.
All right. So, I'm going to be getting into a lot of stuff here. I got a lot of slides to cover. How many of you are working with clients or patients with autoimmune disease right now? So we all are, right? Most of us are. And we're seeing a lot of the same stuff. I'm going to share with you today in this talk, this presentation, a lot of the clinical observations that I've made, as well as a lot of my clinicians and colleagues have made at my Metabolic Healing Institute, and as well as a lot of the research that I've been doing related to certain specific topics. So let's get right into this. So again, I'm the founder of Metabolic Healing. My name is Michael McEvoy. I offer clinical training courses. I have a True Report software, which is our lab analysis, client management software program. And I also do a lot of research and writing. And that's basically what I do. Okay, so getting right into this. So obviously when you're working with clients with autoimmune conditions, you've got to do the basic fundamental work. You've got to do, as FTNs, you've got to do dress, and you've got to really, really hit every possible angle you can. In my roundtable talk yesterday, I was explaining how it's so critical to uncover the environmental triggers that are setting your clients off. Because yes, there are genetic susceptibilities, but there are a lot of environmental chemical toxins, heavy metal toxins, viral pathogens, which we're going to cover a lot today, that are driving the innate immune system. Who here has heard of the innate immune system? We've heard about it throughout this weekend. Dr. Tom was talking about it, and Dr. Jaffney were talking about it as well. When we talk about the innate immune system, we're talking about one of the oldest parts of the immune system that is the first responder to the threat of danger. So we have to do all of the basic stuff. We have to do our dietary refinement. Dr. Tom was doing a great job talking about that, removing all of the major antigenic triggers, looking at all of the different toxins that are going on, creating a strong foundation. So who was here? Who listened to Jason's talk? That was absolutely phenomenal. A lot of the stuff revolving around circadian biology and creating that foundation is so absolutely imperative. There's studies that show that Wi-Fi radiation disrupts the vitamin D receptor. So we know the influence of these different things upon our gene expression, and we have to get under the hood with this. So you're doing all the basic work. So we're going to talk about today are some of these major driving factors. So viruses in the immune system, the oldest cat and mouse game, as you see from the graphic here of the cat and the mouse, the cat is trying to get the higher edge on the mouse. It's trying to get a hold of that elusive pathogen. And viruses are one of the oldest, the most elusive pathogens that humans have been exposed to. They are in our DNA. 8 to 13% of our DNA are comprised of what are called retroviruses. And we're learning about how these retroviruses are actually involved in the development of different disease processes and what their role is. So science is still evolving. We're still learning about what viruses are actually doing. There's been papers that show that, well, maybe some viruses are actually good. So maybe we need to have them. But clearly, they show up to express in certain people, especially in autoimmune conditions. This is a paper that was published in 2018 linking Epstein-Barr virus to 7 different autoimmune diseases. So this is probably the most common virus. Who here has had EBV or mononucleosis? So actually we probably all have it, we just may have never known it. All of us are about 90% of us or more are going to test positive for the EBV antibodies. from past latent infections. But I'm going to show you today in this talk the two most important and relevant antibodies to be looking at for identifying active current viral replication. So we have lupus, MS, RA, juvenile idiopathic arthritis, inflammatory bowel disease, celiac, type 1 diabetes, all of which have been associated with EBV. This is a paper from earlier this year. Here's a paper linking different types of viruses to type 1 diabetes, which is an autoimmune diabetes. We're looking at Coxsackie, paper looking at rotavirus, mumps, cytomegalovirus. Cytomegalovirus can also inhibit the vitamin D receptor, which is really important. The vitamin D receptor is what we need to activate in order to turn on our immunological response mechanisms and to downregulate the hyperinflammatory response by increasing our T regulatory cells. Who here's heard of Treg cells, Tregs? Tregs are a key part of the immune system. They're a T cell that come in and shut down the hyperinflammatory response. We have to be thinking about ways to modulate Tregs with our autoimmune clients. We do that largely through the gut. So some of these other papers here just kind of rifling through this stuff. So there's a ton of literature linking different types of viruses to different types of autoimmune diseases. This is an important paper that was published in 2015 linking the Epstein-Barr. These are different types of latent membrane proteins that are expressing in a huge percentage of both Hashimoto's and Graves' disease. So one of these latent proteins shown 34.5%, the other one 80% in Hashimoto's. So if you're working with, or you have Hashimoto's yourself, you need to be looking at EBV, and I'm going to show you the two most important antibodies to be looking at to show active viral replication, not PATs or latent. So, and then Graves' disease, 62% showed that one of these proteins were expressed. So what are the major susceptibilities to autoimmune disease? We know that there are a number of genetic links. And as Dr. Tom was talking about the other day, the loss of self-tolerance is a key critical turning point where our body's tissues become a target. And I'm going to share with you some information about the extracellular matrix and our collagen and connective tissue, which can actually become one of these targets that can lead to autoimmune susceptibility. We have on the chromosome 6 region, which is also known as, there's a big cluster of genes in here known as the HLA region, human leukocyte antigen, regions 1 through 3. Who's heard of the HLA region? So in the SIRS research, and this is something that's very interesting, and this is one of the reasons why when I'm working with somebody with autoimmune disease, I am asking about water damage building in mold. Because mold can become a huge toxin that is creating a susceptibility to autoimmune disease. As it turns out, the HLA region, HLA, DRB1, DQB1, these are the same kinds of genes that predispose you to SIRS and mold toxicity as they do to different autoimmune diseases. And so a number of these different genetic factors, the HLA-B27 associated with ankylosing spondylitis, psoriasis, Crohn's, the C4 region, which is some of you heard me talking about RCCX, which is a complex cluster on HLA region 3. This is linked to a number of different autoimmune diseases you can see. Complement C2 and lupus, factor B and celiac. So these are all in different types of complement innate immune genetics that are possibly going on with your clients that they might not know. But you can also have other types of epigenetic triggers. So we're seeing a convergence between the genetic susceptibility and the epigenetics. So the things that are causing your genes to express in different ways. If you have deficiencies in some of these innate immune genes, it can make you more susceptible to different toxins, like your glyphosate, like your mercury, your aluminum, your cadmium, your chemicals, your Wi-Fi. So if you have the susceptibility, the likelihood of being to suffering autoimmune disease is higher when you're exposed to these different toxins. Joint hypermobility and inflammation, so we're going to talk about that and the phenomenon between some of these individual clients that we see with hypermobile joints and autoimmune disease. So the innate immune system, it's the oldest part of our immune system. It predates the humoral immune system. And what you have to understand is that the innate immune system is the early responder to the threat of danger. The threat of danger, viral pathogenic toxin, or your own body's connective tissue can become a target of your innate immune system. And so specifically, when we're looking at the mechanisms of how the body creates inflammation, we're looking at the innate immune system. So the innate immune system is comprised of the complement pathways, of which there are 3, the lectin pathway, the alternative pathway, and the classical pathways. And then the other one that we're going to talk about is the inflammasome. So you heard in one of Tom's slides, Dr. O'Brien's slides a couple of days ago, he was talking about toll-like receptor 4 and gluten and gliadin. That is when that is being upregulated, we are increasing the exact cytokines that produce the autoimmune process. The innate immune system is found in different cells and tissues. The epithelial mucosal barriers, which you've learned about in FDN, this is going to comprise, the innate immune system is in here doing its thing. Natural killer cells express innate immune components, the dendritic cells, and our mitochondria. Who here has heard of the cell danger response? So the cell, I will write that down. The cell danger response, Dr. Robert Navi, his lab is 10 minutes away from here at UCSD, is probably one of the most important scientists in the 21st century studying chronic disease and the underlying mechanisms. What you need to know is that your mitochondria coordinate the threat of danger. And so the mitochondria can turn up and down metabolism and can actually be the key breaking point in whether or not somebody is inflamed or not. So the inflammasome. So the inflammasome activation, what you need to know is that the inflammasome is an intracellular protein complex in different cells, especially different immune cells, that get turned on when there are what are called DAMPs and PAMPs. So DAMPs, write this down, damage-associated molecular patterns, and PAMPs, pathogen-associated molecular patterns. So DAMPs are from your own body's tissues. When you have mold exposure, when you have mercury in your tissues or glyphosate in your tissues, you have different what are called metalloproteinases that will break down your connective tissue and your collagen. So your hyaluronic acid in your connective tissue will be broken apart, and these will be picked up by these toll-like receptors, and this is going to trigger the 2 cytokines, interleukin-1 beta and interleukin-18. Interleukin-1 beta is your major cytokine that turns on the interferon gamma system. Who's heard of interferon gamma? This is one of the key cytokines. It's the main antiviral cytokine. So when you have a virus, your inflammasome is turned on. So the other part of it is that pathogens will also stimulate the inflammasome. AIM and the cyclooxygenase pathway is turned on through interleukin-1 beta. So these are the inflammasome, the key mechanisms we need to pay attention to. What are some of the possible indicators that somebody has inflammasome activation? So active autoimmune disease, number 1, you've got to suspect that this is already happening. And we don't have enough diagnostic tests or functional tests yet available to really nail it down. You can do cytokine testing, which is tricky and expensive, but we can already know based upon just looking at some of these symptoms. So we know that interleukin-1 beta is associated strongly with Hashimoto's, with lupus, with type 1 diabetes, with Graves', RAMS. And what about sudden onset hypermobile joints? So there's certainly congenital conditions where somebody can be hypermobile, but I've had many clients tell me that they suddenly became hypermobile after they had chronic illness, after they developed an autoimmune disease. And that is because the collagen is breaking down, and their body is basically boring holes in their connective tissue, and this leads to tremendous inflammation and inflammasome activation. So MCAS, this is associated, so mast cell activation, this is associated with interleukin-1 beta. That's an inflammasome indicator. High pathogen load, fever, that stimulates interleukin-1, or that's indicative of interleukin-1. And then these toxins are known to stimulate the toll-like receptors that turn on the inflammasome: aluminum, mercury, cadmium, silicon, asbestos. There's probably many more that haven't even been studied yet. Vaccine adjuvants, there's many papers that show that vaccine adjuvants stimulate the inflammasome, leading to chronic inflammation. The modulation of the inflammasome. So some big takeaways, these are keys. We know that one of the reasons why caloric restriction and fasting work so well in some patients with autoimmune disease is because they're turning on the AMP kinase system. Has anyone heard of AMPK, AMP kinase? So these are really important protein systems in the cells that regulate different metabolic functions. This is really like a yin-yang balance between AMPK and mTOR. So fasting and calorie restriction turn on AMP kinase. Exercise, cold exposure, as Jason was talking about, cold thermogenesis. You all like to run in the snow naked, right? This is at least I do. Jumping into cold poses. This is going to stimulate our AMP kinase to inhibit the inflammasome, hyper-inflammatory response. You can also use different botanicals: berberine, bitter melon, lipoic acid. What do you notice about these? These are often useful in type 2 diabetes, right? Similar things. The inflammasome gets turned up in that condition as well. Who knows about beta-hydroxybutyrate, so the ketone you make in your liver? So this has also been shown to inhibit the inflammasome. So we can use different dietary things, fasting and fasting, to help downregulate the hyperinflammatory response. Ketosis, fasting, resveratrol. This is all going to turn on autophagy. Autophagy is like the cell janitor system that comes in, cleans up all these unfolded proteins, all this intracellular junk. And when we do that, that's helping to just clear out and detox the cells. Okay, the complement immune system. So Dr. Gupta and a lot of the SIRS doctors are talking a lot about this, and you can run different types of complements. The most commonly run are the C4. Sometimes you'll see the C3 and then the split proteins getting run. The innate immune system, the complement immune system is comprised of the alternative lectin and classical pathways. Very complicated when you start to look at what these things are doing. But what we need to know is that they're creating different types of adhesive bonds to pathogens. And these adhesive bonds basically have the goal of opsonicizing the pathogen or toxin, or creating some sort of working with an antibody. And the opsonization is basically you're blowing up the toxin, you're blowing up the pathogen, the virus or the pathogen. So here's a little graphic of the complement immune system. So some of the main players here, as you see, C4A, very complicated as you get into it. But as you learn, this is an important slide. I would take a shot of this one. So this is all based on research. I'm not making this up. You could mine the literature and find all this stuff. There's probably many more complement immune deficiencies. But the deficiencies of complement are very common immune deficiencies worldwide and are strongly associated to a number of different autoimmune diseases, you can see. So lupus, C4, C1Q, C1R, C1S, C2. So the bottom line, the big takeaway here is that if you're working with a client that has any of these autoimmune conditions, there's a higher probability that they are deficient in certain complement proteins. That is an immune deficiency. That means that they're not able to complete a certain critical part of the immune system process. And so what can we possibly do about this? I'm going to show you in a couple of slides one workaround to this potential problem. One thing I wanted to, a few highlights here on this slide, the mice bred to be deficient in C4 were shown to have decreased frequencies of Tregs, T regulatory cells. Remember we talked about that? So the Treg cells, they come in and they clean up all the inflammation. They say, all right, we're shutting it down, guys. That's it. No more inflammation. Time to repair. So if you're deficient in C4, your ability to turn on your Tregs may be impaired, at least from a mouse perspective. Hashimoto's and Graves', interestingly, the thyroid tissue has been shown to feature increased expression of C4. So there's a lot of toxicity happening in the thyroid tissue itself. Okay, moving through it. So sugar is some of the most powerful immune weapons, and we can use different types of monosaccharides and polysaccharides to modulate the complement immune system. And there needs to be more research on this, but I was able to find some literature that showed that all these different substances in some way modulate different parts of the complement system. So beta-glucans, for example, from our medicinal mushrooms like reishi, maitake, shiitake, these can increase the complement functions. So again, remember the complement, especially the lectin pathway, is creating a sticky bond onto a pathogen. So we need to create, most of our immune complexes in our body are glycoproteins, sugars bound to proteins. So we need to use these, we can use these polysaccharides and these sugar complexes to our advantage. I've used all of these. There's some really good specialty products, some of which can be remarkable in some cases. The Digesti-Cure product from Drucker, the Autoimmune X, which is aloe vera, that can be strong stuff. So there's different ways of using this stuff. The brown and red algae. I've also seen in some cases how the polysaccharides can help reduce hypermobility of the joints. So there's a percentage of individuals with hypermobility that have autoimmune disease. So you're looking at connective tissue problems, connective tissue dysfunction. We can use different things to modulate that. The sugars, interestingly enough, the complexes of sugars are actually key to create glycosylation of our immune cells. All right, moving through it, Epstein-Barr virus. So I promised to get into this. So most people have been exposed to Epstein-Barr virus, but there's some people in the population that show an increased expression of EBV. And it's happening, their body is basically, Epstein-Barr is recirculating. It's replicating actively. And so we have to look at the mechanisms that are leading to the reactivation of EBV. Now, in terms of antibody testing, there's only 2 antibody tests that you really need to look at to identify active viral replication of EBV. The viral capsid and the other one, those are past indicators. That means you've had it before, but the 2 that we know that are associated with active replication are the early antigen IgG and the IgM. If either of those are high, that's indicated you've got somebody that's got active Epstein-Barr. You can also use Armin Labs in Germany. Who here has used Armin or heard of Armin? We're one of the sponsors, but anyone here can open an account with them in Germany, and you can run the T-cell ELISpot. This is a T-cell lymphocyte test, different than a B-cell antibody test, so it's actually showing more of an inflammatory marker. Here's a couple sample tests. So the one on the left here, you see the early antigen is high at 150, and that's greater than 150. That's indicative of early antigen EBV activation. There can be some cross-reactivity with other viruses, and you can rule those out if necessary. The hepatitis A and C and HIV. The one on the right, that's the Armin Labs T-cell ELISpot, showing the T-cell reaction to Epstein-Barr. Here's the IgM that's elevated in an individual here. As you see, 67 is the titer for that. So these are the tests to be looking at. Again, the early antigen antibody and the IgM. So some key antivirals. So really getting into this research and this work. There's a good paper that shows the effect of high-dose vitamin C on the ability to lower the early antigen in the IgM and the Epstein-Barr virus. That was done on an intravenous study where they're doing 30 to 50 grams or so intravenously. But obviously that I've referred clients out to that, and they definitely feel better when they do it. You can use the liposomal sodium ascorbate. There are a few papers that show that sodium ascorbate has been used as an antiviral. It's a buffered form. Who here's heard of Bravo yogurt? Have you ever used Bravo? Bravo is a yogurt from Switzerland, developed by Marco Ruggiero. It's a very potent immunomodulatory. It contains about 250 different active immune-modulating peptides, including GCMAF, which is believed to be can inactivate what's called nagalase, which is a kind of a viral protein that gets released. So this is really strong stuff. You got to be careful with the Bravo, especially if you got somebody who's really inflamed. Start at a tiny dose and slowly graduate up. I had a client that she went too fast on it, started getting head pressure and tinnitus just for the first time, and then we had to really go way back. She eventually tolerated it well, and she did way better once we went back and titrated up slowly. Chinese skullcap contains a constituent called bicolin, Scutellarium bicolensis, and this is a strong antiviral. BHT, butylated hydroxytoluene, antigraphis. These are all kind of the things that I like to look at using. So let's look at a quick case study here. This is a female age 60. She's been diagnosed with celiac and Hashimoto's. She's got a history of HSV2 and EBV. She's got hypermobility, pain, extreme fatigue, all this stuff. This was her current regimen when she came to see me. This is her blood work. So I used my True Report blood chemistry software to basically track her progress over time. We see that, this is kind of highlighting a few things. The electrolytes are off, high sodium and potassium, elevated bicarbonate, so she's definitely got some electrolyte tissue hydration issues. Got to focus on that, that's one of the fundamentals. And then here on the right, just looking under the CBC, this is one key way to identify viral expression that's leading you to think, there might be a virus here by looking at this. A low white blood cell count of 3 and 3.3, anything less than 5 is suspect, especially if the monocytes are high. So monocytes migrate to the tissues we call macrophages, and they release your interferon gamma, which is your antiviral cytokine. Also, it's not on here, but if the lymphocytes are high, that's another key, percent lymphocytes are high, that's another key indicator of viral stuff. So there's clearly stuff going on here. So your TPO antibody at 171, that's coming back elevated, and her thyroid markers, as you see, are a little bit low, T3 and the free T3 are low. So here's the initial protocol. And she was already doing a lot of diet stuff correct. She was already been working with a functional medicine doc. We basically I said, let's just go with this basic antiviral protocol. So the CBD, phenomenal, improved her symptoms in just 2 weeks. After 6 weeks of this whole thing, her fatigue went down from an 8 to a 3. So the viruses can cause a lot of pain. Viruses love to hide out in neural tissue. A lot of times we've got viruses living in our ocular nerves or in our vagus or in the celiac plexus. They like to hide out in the neural tissue and cause pain and all kinds of problems. This was the follow-up protocol, so we kept going with the hydration. I added the Autoimmune X digestive here, which are polysaccharides, mannan, polymannan, glucomannan. She tolerated it well. A few other things were added here. Collagen to help the connective tissue. So she was doing pretty good. Here's a follow-up. So she still got some work to do. The electrolytes did improve a little bit. The potassium improved 11%. And we see the iron went up a little bit. So there's things that are happening still needing work to be done. We see, though, that her white blood cell count improved. It went from 3.3 to 5.4. That's a big indicator. We see that some of the other stuff improved. Her monocytes came down 20%, and she was feeling better. But interestingly enough, her thyroid markers improved, including her TPO antibody came down 40%, so 171 to 101. So this is data tracking. This is something that I definitely recommend following when you're working with clients like this. You're wanting to look at specific biomarkers to help you get an indicator of what you need to do. Even though we didn't actually focus on her thyroid function, her thyroid function improved by itself. So her free T3s you see came up, as well as her total. Okay, so vitamin D testing. So the roundtable discussion yesterday, who was listening to the roundtable stuff? So how many of you are doing or looking at vitamin D tests? How many of you are looking at the 125 dihydroxyvitamin D and the 25 hydroxyvitamin D? Okay, right. So there's some of you who are. Some of my own practitioners that I've trained actually doing that. So what you have to understand is that measuring only the 25 hydroxyvitamin D by itself is futile. So we have to look at vitamin D more and from a functional perspective and less from a quantitative nutrient perspective. And the reason for that is that what we're looking at clinically and all the data that we're looking at from just a clinical standpoint is showing us that we need to be looking at both of the active form and the precursor. So the calcitriol, which is known as the 125 dihydroxyvitamin D, that's what binds to your vitamin D receptor. That is what turns on your macrophages and your immune system. That's what does all of the things that we need vitamin D to do. But if you're only looking at the 25 hydroxy, you're not getting an accurate picture of what's really happening. The ratio between these two should ideally be very close to 1:1. And for those of you that are running both of these tests together, how many of you have seen that the calcitriol is twice as high as the 25? So we've seen it, right? And you're seeing it in viral expression, Lyme disease, in chronic illness. So there's something going on in that pathway that's causing problems. And what we're seeing is that when that ratio moves closer to 1:1 is when your symptoms are starting to improve. So we know about the different effects of vitamin D. Vitamin D is critical. The active secosteroid hormone that binds to the vitamin D receptor, which is calcitriol, is a GC-MAP. The vitamin D binding protein is a GC-MAP. This is what activates our macrophages. This is what generates and creates our self-tolerance by improving the function of our T regulatory cells, critical to upregulate those T regs and autoimmunity. VDR activation inhibits mast cells, modulates T and B cell lymphocytes, all of this stuff. Some of the other stuff too, bile acids, hormones. So there's all kinds of issues here. This is a sample test from a client with Hashimoto's thyroiditis. So we see her 25 hydroxy, 26.9, her calcitriol, and guess what? She was taking vitamin D3. Well, why is it not budging? Because there's something else that's going on here. So we know, looking at some of the literature, what viruses can do. So this is a biochemistry diagram. And this is not meant to be very detailed because there's actually a lot of feedback and negative feedback loops, but just to give you the idea that foods, as well as UVB light, contain all the precursor stuff that will lead to the hydroxylation of the 25 OH through these two-sided chromes. And then you make calcitriol. Now, some of the Robert Navio research in cell danger response is showing us that calcitriol, which is the active hormone, can be inactivated in certain danger signaling states, leading to inactive metabolites, that 24-alpha-1 pathway. So this is probably happening in chronic inflammation. But here's what you really need to know. According to the literature, these are the 5 known factors that can inhibit or augment how calcitriol binds to that vitamin D receptor. Lyme borreliosis, Epstein-Barr virus, cytomegalovirus, Wi-Fi radiation, and gliotoxin. Gliotoxin can be produced from Aspergillus, Penicillium, and Trichoderma. So if those are going on, you could start, that could very well be a reason why you're seeing that calcitriol is higher than the 25. And when you start to work on that level, you start to see that ratio moving closer to 1-to-1. That's the study that shows the relationship between, this is an in vitro study about how the EBNA Epstein-Barr protein inhibits the vitamin D receptor and inactivating its target genes. So viruses have a machinery. They have a type of intelligence that are working on a level of altering intracellular processes, hijacking, turning off certain key genes that your immune system would otherwise be using. Who here has seen clients that have Hashimoto's that have hair loss, females especially? Yeah, all of us, right? A lot of us. So this is a common thing. And so I for many years have been wondering, well, what's causing this? What is the relationship between? I thought, well, maybe it's superoxide dismutase, maybe it's the high oxidative conditions, and maybe that's part of it. But this is an interesting paper that was published earlier this year that showed that in alopecia, that all of the subjects with alopecia had reduced vitamin D receptor expression. So they concluded that this is a significant correlation. But they were testing the vitamin D levels to the 25, not actually the calcitriol. So if the researchers are actually looking at the actual hormone, we'll probably get different data. But nonetheless, it's still very important to understand that alopecia, hair loss, correlates with vitamin D receptor inactivation. So what's my theory about it? Well, possibly that because Epstein-Barr has a 30 to 80% association with Hashimoto's, and Epstein-Barr, as well as some other pathogens, can inactivate the vitamin D receptor, it seems very reasonable to think that that could be the reason why hair loss is happening. And clinically, I've seen that when you improve those immune functions, you start to see the hair loss improves. It doesn't fall out anymore. So this is an interesting thing. So you want to start looking and thinking on this level. Okay, so some of the key takeaways here. Again, testing the 25-hydroxyvitamin D by itself, it's of limited value. We have to be looking at both forms together. We want to be looking at the calcitriol with the 25, and ideally this ratio is close to 1-to-1. When we see chronic infections, chronic illness, it's often 1 to 1.5 or 1-to-2, calcitriol being higher. Sometimes in insulin resistance, you see the opposite scenario. You'll see that the calcitriol is low and the 25 is high. Sometimes vitamin D3 supplementation can cause too much 25 to go up. So it's suggesting it might not be utilized, it might not be converted quickly into the active hormone. So supplementing with vitamin D3 is often useless because it fails to address the functional changes of vitamin D metabolism and the subsequent VDR inactivation that may be taking place, which can be attributed to many different pathogenic influences. So lower the inflammatory burden, do all of your fundamental work that you're already doing. And I should emphasize that, is that this stuff may seem a little bit more advanced and complicated, but really ultimately, you've got to go back to the drawing board and you've got to refine all of your basics. And this is one thing that I always emphasize and teach all my clinicians is you've got to go back to the basics and you've got to hit those and you've got to do all of the initial work. You've got to go back and really ask the questions. Do you live in a water-damaged house? Have you been exposed to different types of viruses? What's your family history? Is there autoimmune disease in your family? You're looking to form an impression. Where's the genetic susceptibility? What kind of chemicals, what kind of body care products are you using? These things can be major stimulants of the innate immune system, which we're needing to definitely think about. So sun exposure, obviously we know about the importance of this. It's the best way to get vitamin D, natural light. And subsequent use of therapies to address the pathogenic and viral load that we suspect is contributing to the dysregulation of the VDR. There have been a few papers that looked at boron, which is a really underappreciated trace mineral. And sometimes I go down rabbit holes. I usually go down rabbit holes most of the time. But one of the rabbit holes I went down, for days I was kind of just obsessed with boron, and it was just the amount of literature that existed on what that does. I was perplexed. It is increasing testosterone, lowering sex hormone binding globulin, and enhancing vitamin D metabolism. Really interesting research on that. So one of the papers said that, well, maybe acting to increase vitamin D metabolism by inhibiting that 24-hydroxylase gene, which is what kind of gets turned on in that cell danger response. There was a paper that showed that Lactobacillus reuteri, this specific patented form, the 30242, can increase the 25-hydroxy by 25%, but more importantly also increases the Tregs. And so, who here knows about reuteri, Lactobacillus reuteri? So about Tregs, there's been a lot of papers that show the modulation of those Tregs by Lactobacillus reuteri, different strains of it. This is just a basic probiotic bacteria that's got a lot of good research behind it. We can use this with our autoimmune clients because it's helping to generate self-tolerance. It's helping to generate, improving vitamin D metabolism. And especially if our clients have suspected complement immune deficiencies, we want to be targeting the gut. Reuteri is one of those strains. It's found in breast milk. So I don't know when somebody is going to eventually make a human breast milk probiotic. But GC-MAF, I should say the Bravo sort of comes close to that. So use of Bravo can activate those macrophages, can function to improve the vitamin D binding proteins, and you've got to turn off the Wi-Fi net. That's so important when you're working with these clients. The 5G is coming, and you got to really, really pay attention to what the implications of that are, because we know the Wi-Fi is going to inhibit that VDR, and we have to turn that VDR on when we're working with these kinds of clients. So we got about 10 minutes left. So I have a whole panel of different courses that I've made over the years. And functional nutritional blood chemistry analysis, I recommend this for most of the FDNs that are just graduating or kind of in the middle or moving towards it. This is going to train you, and we use the True Report software with that. So you can come talk to me at the booth. We've got some sales going about this conference today. All right, so that's it. Questions?
So if you're supplementing with vitamin D in a situation where the person's highly inflamed and has a lot of infections, are you actually bypassing their body's own protective mechanisms and causing harm?
That's a good question. That's been debated, and some of the work of Stephanie Sennett has kind of pointed to that. There's a sulfation process that has to happen, and when you're taking it from a non-natural form, you might be missing out on certain key steps. Are you creating harm? That's a good question. It's possible. I'm not opposed to using vitamin D3, but I'm also very cautious with how I use it because I think that it can easily be overdone. And we can get vitamin D from the most important sources, like foods that have fat-soluble vitamin D in it, a cold calciferol. So I think the jury's still out on that, but I think I would be very cautious. It's not where I would not start with D3 supplementation, especially if I see the pattern showing up. If I see the pattern of this calcitriol being higher, I'm not working with vitamin D at all. I'm working on, that's indicating to me, that's a functional test. It's telling me that I need to focus on something else.
If you're seeing viruses with your clients, how does this all play in if you're presenting with parasites, bacteria, dysbiosis? Like, what's your kind of protocol in terms of priority?
Yeah, that's an interesting question. So there's different kinds of bugs, as we know, and they can do different things. There's actually research in terms of parasites. There's actually a lot of research that show that certain parasites can create a Th2 response, and that might actually be a benefit to people with Th1 autoimmunity. Oddly enough, and there's been papers that show that helminthic therapy is actually effective in multiple sclerosis. I had a client years ago, 21-year-old male, who developed 5 or 6 brain lesions, diagnosed with MS, went to university somewhere in Michigan to do helminthic therapy, parasite therapy, ingesting parasites, hookworms, Diminutia helmintopoulos, I believe, and all of the lesions went away in 6 months. And so it's kind of leading us to kind of question, well, what's going on there? We normally think of treating pathogens because they're driving factors, but I think it's telling us that there's more we don't know about microbiology yet. But to answer your question in terms of what I would do is, I don't know if there's any one set sequence. Oftentimes with a lot of natural products that you're using, you're covering a lot of bases simultaneously. So if you're using bitter melon and bakelin, for example, you're probably working on more than viral activity. And a lot of the problems that we see are related to your own immune system's inability to resolve the threat of infection, and your own immune system's inability to stop its inflammatory response. that we have to look at that as being actually probably more fundamentally important than the actual pathogen itself, is your own immune system's response to it. So what we're trying to get today is ways of how can we correct some of these suspected immune deficiencies and compensate for some of the genetic weaknesses that some of us have. So there's no right or wrong sequence of when you do it, but I think that we have to just kind of intuitively go by what we think we need to do in each case.
What can we do in situations, like my daughter just went up to college, she's living in the dorms, she's really good about following her nutritional protocols, but she is saturated in Wi-Fi, and there's no way to turn it off at night because it's provided by the school. What can we do to help ourselves if we're in a communal living situation, our children when they're in a communal living situation, to protect themselves from the Wi-Fi, especially at night?
Yeah, this is a big problem, and it's not going to go away anytime soon. I will say that there are some companies that have made some kind of different products and clothing that you can wear that can repel to some extent some of the Wi-Fi. Use some of these. I know Aegis Corporation has some of these products. AEGIS. There's a lot of other companies that are starting to come up. There probably needs to be more. There's paint primers that you can use. I know that aluminum is a really reflective material for a lot of the Wi-Fi. Certain doctors actually have patients wear special clothing that's Wi-Fi repellent. I've used that to some extent. I think it does work, at least to some extent. We have to be more creative. I know that you can use Mylar, which is your natural kind of heat insulator. Mylar completely blocks the EMF. So if you wrapped your phone in Mylar, you couldn't make a call. No call would come through. So you could have your daughter wrap the whole room in Mylar. Ellen?
So I want to make sure I understood, when you made a reference to retroviruses,
Yeah.
I want to make sure I understood. You said that they're actually born with retroviruses and it's in the DNA?
Okay, yeah, so I briefly mentioned retroviruses, and those are different than your herpes simplex virus. So retroviruses are known as RNA viruses. And there's two classes of retroviruses. Endogenous retroviruses and then exogenous retroviruses. So the ones that are exogenous are the most commonly known as HIV. So that can be infected or acquired. And then HTLV1. And then there's, according to some researchers like Judy McEvoy, there's probably many more retroviruses that exist, XMRV possibly. Those are exogenous retroviruses. We don't actually know enough about that. But then we have endogenous retroviruses. And actually 10 to 13% of our genome is made of these endogenous retroviruses. They're in our DNA. And they played a significant role in our evolutionary process. For example, some retroviruses like HERV-K and HERV-W are involved in forming the placenta and in brain development. So they actually play a beneficial role. But they can also show up in autism and autoimmune disease and are believed to stimulate the inflammasome through forming PAMPs, pathogen-associated molecular patterns.
Two quick cues. With the tinfoil and the clothing and everything, isn't it possible, I listened to a couple podcasts by McCullough, to create an echo chamber with those things? So if you're wearing a shirt, you actually end up having the Wi-Fi come up through your skin or something and just bouncing around in that supposedly reflective material. Is there a risk for creating an echo chamber there?
Good question. No idea. That's interesting research worth looking at.
Okay, second question. One of the things I really want to work on with my clients is not just getting them from a inflammatory, bad health state and back to normal, which is where a lot of people, clients stop. I want to focus on building that resiliency and giving them ways to, when they're traveling abroad or something, ensure that they're a little safer. So besides things like mushrooms, which we know upregulate certain parts of the immune system, what other things would you recommend adding to not upregulate the immune system in a bad way, but prepare it for higher toxic load, pathogenic
So
load
specifically
environments?
for traveling?
Sure, let's go with that.
Yeah, so always the gut is kind of the central focus there. Always making sure that bowel function is optimized. I would really look at that. use of binders, especially for travel. You know, there's a lot of good ones out in the market that even didn't exist a few years ago. And I think that the more toxic our environment becomes, the more we have to look at different kinds of binders that prevent. One of the problems with toxins and endotoxins and certain bacteria, lipopolysaccharides, and heavy metals and chemicals is that when our liver dumps it into our intestines, into the bile, through the gallbladder, this bile gets recirculated, redistributed. And this is one of the kind of the main problems with mold, as you learned from Dr. Gupta's course, is the recirculation into the second pass metabolism of the bile, which contains all these toxins. So we can use different binders to prevent, to some extent, a lot of the recirculation of this stuff. And this is going to be I think this is a key thing going forward, because the level of toxins in our environment is not going to get any less anytime soon.
Awesome, thank you.
I had a question about the hypermobile joints. If that's something, like you spoke about it being like a sudden onset, but what if something that somebody has that's, I don't know if there's different levels of the congenital stuff of the genetics and what kind of things that makes people more susceptible to as clinicians, if we see that as a clue that somebody has that, what kind of things would we be keying in on?
Thanks for bringing that up. This is actually a central area of focus of research I've been doing for a long time now, and it's starting to show itself to be really significant. So hypermobility, joint hypermobility doesn't always, but it can be a huge indication that something is really wrong, or there's a weakness or a predisposition. So there's obviously congenital conditions like Marfan syndrome, Ehlers-Danlos syndrome, that are congenital hypermobile conditions that can be very serious. But then there's kind of this other class of patients that they don't have any definitive diagnosis, or in some cases they'll develop hypermobility as a result of some chronic illness that they've had. So it's important to kind of look at this from the context of what is this, and why do they often have some of the sickest patients in the population are hypermobile. They have a lot of these other comorbidities. They have an MCAS, POTS, autoimmune disease. There may be family history of schizophrenia, bipolar, PTSD, autism. So all these other kind of overlapping syndromes in the family. And there's probable genetic links to this. I did research on this. I made a course on this. It's called RCCX. It's a gene cluster. This is one of the probable links to this phenotype that has these things going on. But there's many different degrees of it. We have to look at hypermobility in the context of some degree of dysfunction to the extracellular matrix. So the ECM is kind of everything that's happening outside of the cell. Because normally, biologists look at, let's look at all this stuff in the cell. Biology, biochemistry, genetics, and let's just, be as reductionist as we can. Forget everything that's going on outside, and we realize that connective tissue and the collagen hold the whole thing together and modulate all these growth factors and immune factors. So that connective tissue can get broken down, and in the case of what we're talking about today, can form DAMPs, damage-associated molecular patterns. Your own connective tissue can be broken down by these metalloproteinases and stimulate the inflammasome and lead to hyperinflammation. And then you start to see, tissue hypoxia problems and discoloration of the fingers and all kinds of stuff going on that is largely related to this kind of ECM disruption. And a lot of the Germans were looking at this research in the 50s and 60s. A lot of Kissinger, Hein, and some of these other guys were looking at this stuff. So I don't know if I answered your question. Did I?
Maybe one or two more.
You mentioned that we should be mindful of the ratio between the 25 and the 125 vitamin D, but is there a level that we should be striving for, an optimal level?
For each individually?
Yeah, or the 25 is monitored.
Okay, so the individual values, the optimal, I'm looking somewhere between like 40 and 90 in US units for both. They should be very similar, they're somewhere in that range. But functionally, I'm looking at both together. So somebody could be truly vitamin D deficient, but I would really only kind of consider that if they were both low.
I see like 65 being a level, say for the 25, and then maybe the 30s for the 125. So that's somebody that's been supplementing with vitamin D.
Yeah, supplementing can cause a higher 25.
So that person should then decrease the dose? Or?
It probably is leading to they're not using it. It's not being used fast enough, or it's not converting as well. There's a lot of other steps. There's sulfation that has to happen too. So if they're not sulfating right, that could affect the conversion of that cholecalciferol. Maybe one more.
Michael, can you repeat a little bit about the test that you were running for EBV specifically, and the difference between early nuclear antigen and
The
nuclear
IgM.
antigen? Yeah.
Yeah, so the IgM antibody testing is usually reflective of an immune response that's happened very, very recently. And the early antigen is it's associated with different kinds of proteins that get released as a result of that. Even though it's an IgG, the Mayo Clinic talks about that as being those two being the most relevant. Is that?
Yeah, and what about the early nuclear antigen?
The EB, yeah, that one is that. If you look at the criteria, that is associated. That can be associated with current, but it can also be associated with previous past.
Okay.
So it's not, even if it's high by itself, it's not enough.
Right, you need the others to correlate with.
I mean, ideally, the antibody testing is still kind of not. It's probably not as good as the T cell from the Armin, to be honest. I think if we had better availability and more technology, we could move that one forward. Because that's more inflammatory. That's telling us, here's your T cells.
Fantastic, thank you.
Thanks, guys. Good questions. Thank you.
Thank you.